Next, let's talk about inheritance. Now, this is not the only video we'll have on inheritance, but this will be our basic introduction. I've got my basic triangle class. It has a side A and side B, right? This.A is A, this.B is B. We've got getArea, getHypotenuse, and describe, which returns, I am a triangle with area of whatever this.getArea evaluates to. I'm a triangle with area of 6. I'm a triangle with area of 20. Whatever it is, that's how our describe works. This is a silly example, but let's imagine I want a different type of triangle that's very, very similar. Still has a side A and B. It's a right triangle. It still has getHypotenuse. It still has getArea. But it describes itself differently. It returns runs and hides in parentheses when we call describe. One way of implementing this is just literally to duplicate everything from our triangle class. I'll just do that here. Change this to shy triangle, and then just change the return here for describe to be whatever we want, runs and hides. That works. There's nothing technically wrong with that as far as JavaScript is concerned. It's just a lot of duplication. And then if I decide, my code is expecting a method on each one of these classes to be called, I don't know, instead of getHypotenuse, maybe it's called getHype. Doesn't really make sense to do that. But now I have to change that in two places if I want to be consistent. If I want to rename my sides instead of A, I want it to be side A. I'm going to have to do that down here, or else it's going to be really inconsistent. I mean, JavaScript doesn't care, but the rest of my code is probably going to want things to be consistent and have a familiar interface. Our sides for a triangle are A and B. No matter if it's a shy triangle or an arrogant triangle or a colorful triangle or whatever class we could come up with. So, as you probably imagine, there's a better way of doing this. Instead of duplicating all of our code, we can inherit functionality from a parent class. So I can say that a shy triangle class extends, and that's the keyword that makes it all work, the triangle class. This will inherit functionality from the parent class. The terminology here would be this shy triangle is the child class, the parent class is triangle. You'll also hear people call this a subclass, and then the parent class also is known as the superclass. And we'll talk more about the word super in the next video. So if I rewrite it like this, it allows me to delete pretty much everything, except for wherever there are differences between my classes. So I'm going to say shy triangle extends the plain old regular triangle. That means it will have access to its constructor. It has access to getArea. It has access to getHypotenuse. The one difference now is that we have a different version of describe here compared to the parent class. So let's see it in action. Let's make a new instance of shy triangle. Also, one thing that can be a point of confusion, my triangle class is changed in no way. That was a bad way of phrasing that. It is unchanged. There is no change at all to triangle. It's still the same old triangle. I can still make a regular triangle. Const, I'll call this regular tri, equals a new triangle with the sides of 3 and 4. But I'll also make a new variable called shy tri, which is a new shy triangle with the sides 3 and 4. And if we look at my shy triangle, it has A set to 3 and B set to 4. I didn't do that anywhere in here. But I extended triangle, which has a constructor, and remember the constructor is automatically called when you instantiate a new instance of a class. You don't call it yourself. So when I made a new shy triangle, JavaScript looked for a constructor in here. It didn't find one. So then it just relies on the parent class version. The same is true if I try and call something like shy tri.getArea. That is not defined on the shy triangle class, but that's okay. It's defined on the parent class called triangle, and it still works. I get 6. I can do getHypotenuse. I get 5. But I can also now do describe, and we'll see something a little bit different than what we'll see with our regular triangle. So shy tri.describe. We get runs and hides. But remember I made this regular triangle as well. If we look at regular triangle and I call describe, I am a triangle with area of 6. So our regular triangle uses this describe because that's all it knows. Our shy triangle uses this describe. You can think of JavaScript as going in order, looking inside of this class first. If I'm calling a shy triangle instance dot describe, it will look to see, is there a describe in here? And there is, and it uses it. However, when I call getArea, that is not defined in here. So it will look up the chain in the triangle class, the parent. Is there a getArea method? Yep, there is, and it uses that one. Okay, so that's our first basic example of inheritance. Now, of course, I can do other stuff in here. I could have some other method called beShy. Terrible, but we'll just have it return I am shy. So this does not exist anywhere except shy triangle. So if I make a new regular triangle, of course, I'm not going to have access to that. Right? If I make my new triangle and call try.beShy, that's only existed, or it only exists on instances of triangle. Now if I make a new shy triangle, and I call shy triangle.beShy, no problem. So by using this inheritance, I can avoid duplicating this logic, and this logic, and this logic, and instead just make small changes, or sometimes big changes, where I can share some functionality from a parent class, get access to all of those methods and those properties, and then add on some additional stuff, like a different version of describe, a different result, or a beShy method. Or as we'll see in the next video, maybe even completely different